My name is Brandon Wright, Senior Applications Engineer with Olympus, based out of Houston, Texas. In this video, we'll go over a basic phase array weld inspection setup and calibration on the OmniScan X3. Stay tuned for a follow-up video in the Olympus Around the World series where I'll cover a dual-sided encoded phase array setup. Let's get started. First thing I'm going to do is create a new setup file from the File drop-down menu. From our new setup, our first step will be to navigate to the scan plan. In our scan plan, we'll set our part and weld. So we got mild steel already selected. We're doing flat plate, and our material thickness is going to be 1/2 inch. In the sample we're going to be inspecting here, it's got a single V butt weld with a 30-degree bevel. So the default parameters are okay. We'll go to our probe and wedge tab. We got PA linear selected. So we're going to run a A31 series 32 element probe, 5 megahertz. And we will select our wedge from the SA31 series. It's a N55S wedge. And we'll navigate to our third tab here for our groups, and we'll configure our focal loss settings. So in this example, we'll use a sectoral, but you have multiple options here to choose from. We'll use an element quantity of 16 on this 1/2 inch thick plate with, we'll set that first element quantity. First, we'll adjust our index offset to be just off of the toe of the weld there. And we're going to bump our first element up so we can try to get that first leg to cover that root while utilizing the second leg to cover that near side bevel as well as the volume of the weld. So we can use our scroll wheel here to push the elements forward a bit. And it looks like a start element 12 will give us a good coverage of that root in the first leg as well as the bevel and heat affected zone. So we can go to the next tab here in the bottom right corner. We've got our sectoral starting at 40 degrees, ending at 70 degrees. I'll just bump this up to a 72 to help us in that first leg just a little bit. And we'll use a true depth focus at about 1.5 times the thickness. So we'll do 3/4 of an inch here. And you can see our focal zone pop up in the scan plan. Once that's configured, we can select done. And we'll pop a little calibration block up here. We'll utilize the side drilled holes for our calibration. So after navigating through the scan plan and configuring all that, we'll go into our UT settings and make a few slight adjustments. So our range is good. We got coverage of our root, plus in the second leg, we can leave that alone. I'm going to turn my voltage up to 115. Get us a little bit stronger signal in there. Go to our next tab here to our receivers. Let's use a 5 megahertz bandpass filter with our video filter on. So I'm just going to adjust my A gate here. So by tapping the start of the gate in the A scan, I can use my scroll wheel to move that gate down in time, as well as the width. If I tap the end of the gate in the A scan, I can do the same thing. All right, let's set our angle selector on that middle hole here, and we will just do a quick auto 80 by tapping the gain and using our auto 80 function. So from here, we're ready to get into our calibration. So we'll go to our drop-down menu, select plan and calibrate, and our PA calibration. First thing we'll do is a wedge delay, which will use this 1 inch radius on my block here. Get a little bit more couplant. There we go. All right, so we've already got it set on radius. So all we have to do is set our radius here to 1 inch. It will automatically adjust our gate, so we can, if we need to adjust it further, we can do that in the next tab here. So I'm just going to raster my probe across this radius. Try to peek it out across all the focal laws, and we'll select calibrate. Once the calibration is done, we'll raster it across again to verify our wedge delay. So we'll give it one more go here to try to get our higher angles a little bit closer to that tolerance. Go ahead and clear my envelope. There we go. So wedge delay checks out good. We're within our tolerance here that we can set on the first page of 0.04 of an inch or 1 millimeter. So now I'm going to accept our wedge delay calibration. And then we'll move on to the sensitivity tab. So I'll get back over to my side drilled holes on my block. Drop a little dab of coupling on there. So for this example, we'll run our sensitivity calibration on this first hole here at 3/8 of an inch. So I'll go to my gate A. I'm going to scroll down using the scroll wheel and set my gate around that first hole. Here I'm going to adjust my width. Once my gate's set, I can raster across and get my trace done and perform my calibration. So I'll run it back and forth a couple times, make sure I get that signal peaked out. Run the calibration and do a verification. Looks like we're still a little bit hot in the lower angles there, so we'll run it one more time. Looks like our sensitivity calibration is now within our desired tolerance of 5%, so we'll accept our sensitivity and move on to our TCG. So we'll just build a quick 3-point TCG curve here. So I'm just going to bump it back so I can get my holes on the screen, and I'll do the same as I did in the sensitivity calibration, where I set my gate A on my first point, do another raster across those holes. We're going to select add point. Once the point's added, we can just go do a quick verification of that point, and now we're ready to move on to the next point. So there's no additional steps needed. All we have to do is move our gate down to the next point you want to add and do the same thing. Raster it across, get our trace peaked out the best we can. And select add point. Do a verification scan here. Looks good. We'll move on to our third and last point by adjusting the start of the gate. And perform another raster over those holes. Select add point. Get a little bit more coupling in there. Perfect. So once we're happy with our TCG points, we can accept that TCG. You can also verify the points here at the bottom. So let's accept our TCG and select done. So we got our setup built, part configured, and our calibrations completed. So at this point, we're ready to move on to our inspection. So I'm just going to do a quick scan over this weld here. Get some coupling on there. You can see a little bit of cap geometry, but there's a little flaw there right on the ID. Just keep scanning across. Looks like we've got a far side OD reflector there as well near the cap. And that's about it. So the only next step you can do if you want to add a bit of scanning gain, we can long press on our A scan here, enable our reference, come to our gain tab here. I'm just going to adjust this to 6 dB, and there we can add 6 dB of scanning gain. So that's it for a basic phase array weld inspection setup, single-sided, non-encoded. If you have any questions, feel free to drop it down in the comments below, and stay tuned for more videos in the Olympus Around the World series. Thank you.